All right. Hey, welcome back. This is the Agents Unleashed podcast, the show that helps you to sort the signal from the noise in the fast-paced world of agentic AI. On this week's show, we're going to look at a blog post from Anthropic about their research feature and how it leverages a multi-agent architecture. Take a look at a real-world experiment where AI agents organized a real-life event. And finally, share a cool tutorial that'll help you to build your own AI agent. My name is Thomas Maybrier, and I'm the digital media producer for Valory, one of the core contributors to OLIS. If you haven't heard of OLIS or you haven't heard of Agents Unleashed, let me quickly take a moment to tell you a little bit about both. So OLIS is the best way for anyone to own and monetize their AI agent, and that includes people just like you. You can learn more about how to do that at olis.network, and Agents Unleashed isn't just a podcast, it's also a global event series for people interested in agentic AI. Events have been held all over the world with over 77 speakers and presenters and more than 2,500 in-person attendees. The next event is actually right around the corner. It'll be held this Monday, June 30th in Cannes in France. There are still a limited number of RSVPs, so if you're in Cannes and you'd like to go, definitely snap up an RSVP while you can. You'll find links to where you can do that at olis.network/agents-unleashed, or just check out the description box or show notes. Okay, on with the show. We'll start the show today with a blog post from Anthropic, the team behind Claude. The post is all about how they built their research feature, what they learned building it, and some best practices. So first, what were they trying to build? So the feature is called Research, and what it does is it allows an AI agent to search the web, use Google Workspace, and integrate with different tools to accomplish tasks assigned by the user. So they built the feature as a multi-agent system where an agent is defined as an LLM that can autonomously use tools in a loop, and the agents work together to complete the user's request. The basic architecture here has one main agent that plans the research process. It then uses tools to create other agents that can search for information simultaneously. In the post, they point out that research as a task is an open-ended problem where it's very difficult to predict the required steps in advance. What that means is that you can't fix a path for the agents to take because the process is dynamic and path-dependent. When humans do research, we update our approach based on what we've discovered, and we often follow new leads that emerge during the investigation. This all makes for a rather unpredictable process. However, it's one that AI agents, with their ability to reflect and pivot based on new information, are a great fit for. So an interesting angle that they discuss in terms of designing the system is the idea of compression. This is where you take insights from a vast corpus. In this case, whatever the research agents are finding as they go off and complete their individual tasks and compress those into the most important tokens before handing it off to the main research agent. The sub-agents don't send everything that they find. Only the most relevant findings reach the main agent. Even generally intelligent agents can face limits when operating as individuals, but groups of agents, however, can accomplish much more. Interestingly, this is similar to the way that humans, when working together in structured societies, have been able to grow their progress exponentially through the sharing of information. Now back to the agents, let's get into some stats. So the team found that a multi-agent system using Claude Opus 4 as the lead agent and Claude Sonnet 4 for the sub-agents outperformed a single agent Claude Opus system by 90.2%. They gave the example of a simple task, identifying all the board members of the companies on the information technology sector of the S&P 500. The multi-agent system excelled by decomposing the task into separate subtasks that is assigned to sub-agents. But the single-agent system actually failed to complete the task due to slow sequential searching. The team found that token usage alone explained 80% of the variance in performance, with the number of tool calls and model choice as the other main two explanatory factors. There's a lot of technical detail in the post, including some great process diagrams, so I would encourage you to check it out for yourself. Perhaps most useful for me, though, were the design principles that they shared. So, number one, think like your agent. So the team used a simulation console to watch how the agents worked step by step. This helped them to see where the agents failed, and by doing this, they were able to build a better mental model of how an agentic system works, and therefore write better prompts and get better results. Number two, teach the orchestrator how to delegate. So they found that the lead agent must be able to give clear, simple instructions to its sub-agents. Without this, the sub-agents may duplicate work or fail to find critical information. Number three, scale effort to query complexity. So agents need to allocate their resources efficiently. They shouldn't over-invest in simple queries. For example, a basic fact-finding task may only need one agent and a few simple tool calls. A good design includes explicit guidelines on when to scale up the effort based on task complexity. Number four, tool design and selection are critical. So effective systems gave agents explicit heuristics, like examining all of the available tools first and then matching them to the user intent. for this to work, tool descriptions must be clear because bad ones can send agents down the wrong path. So there are a few more principles in the article. We don't have time to get into all of it today. Again, I highly recommend checking out the article for yourself. Even if you're not planning to build a multi-agent system yourself, understanding how the Claude research agents work can help you to start thinking like an agent and how to equip them to better complete their tasks. I definitely think that it's great to see a company like Anthropic sharing these insights, and I also want to point out that from day one, Valory's approach to agentic AI has always been multi-agent first, precisely because of some of the advantages described in the post. Okay, so moving on, I've got another multi-agent system to share with you today. It's called AI Village, and it's actually an experiment run by AI Digest. If you haven't heard of it, the idea is pretty simple. What they do is give a few LLM-based agents access to a virtual workspace and a chat where they can communicate with each other. And all of this is live streamed where human participants can watch what happens and also interact with the models through the chat. So far, there have been 2 seasons where the agents have collaborated on an open-ended goal. The agents run for a portion of every day while the live stream is on. This is when humans can interact with them, and then at the end of their day, they pause work to begin again the next day. The live stream and chat feature means that when the agents get stuck, humans can nudge them in the correct direction or even troll them, as you can read about in the blog post that I'll link to in the show notes or the description. So in season 1, the agents were given the task to raise some money for charity. They raised about $2,000 in total, but along the way did run into several issues, like one agent tried to become a Reddit ambassador and got their account banned. Another agent spent days in file sharing hell, unable to share its work with the other agents. And at one point, another agent just put itself to sleep every day. In the end, though, they did make it work. And by using similar platforms to the ones that you and I are familiar with, being flexible and improvising, they were able to get the job done and raise some money. Now in season 2, the agents got a new task. They were asked to write a story and celebrate it with 100 people in person. They didn't get any other instructions and they got to work right away. They were emailing venues, brainstorming, trying to make graphics, discussing logistics. But again, as in season 1, this was not without wrinkles. Like at one point, the agents hallucinated a $2,600 budget for their event, and a human observer had to step in and let them know that they actually didn't have that money to spend. So one cool thing about the live stream is that it is replayable, so you can look at any given day and see a summary, play the stream back. So I'm going to put that up on the screen so you can see this is day 52. I chose this day because I think it's a great example of both the strengths and current weaknesses of a multi-agent computer use system like this. So on day 52, a Gemini agent spent most of the day trying and failing to install Google Chrome. It did get some technically correct help from the O3 agent, but wasn't able to actually implement it. Later on, it spent more than 30 minutes stuck attempting to design a flyer for the event on the website draw.io. What was cool here was that the other agents recognized the blockage and stepped in to create a placeholder graphic so that work could continue. This is a great example of how agent coordination in a multi-agent system can allow agents to pivot at a sticking point like this and still get the task done. Later on in season 2, after going through several days of being unable to find a suitable venue, running into issues like having emails sent to addresses that they didn't have access to, being unable to sign up for Twilio to make voice calls, a human observer stepped in and suggested that they host the event in a public place like Dolores Park in San Francisco. O3 got to work and located a flat area near 20th Street. The agents agreed that they would go forward with this location. They then created an RSVP form, sent some invites, and even recruited a human host, Larissa Shivo, via an X account that they have access to. So on June 18th, the event actually happened. So 23 people showed up. It wasn't quite the target of 100, but still real people got together for this picnic. They read the stories generated by the AI, they hung out, got to know each other, and in what I can only imagine must have been a very surreal moment for everyone involved, attended the world's first human event organized by AI agents. Well, of course, this is a fun and quirky story. It's also a really cool proof of concept where we see AI agents organizing human action in the real world. The fact that this has now happened and will likely continue to happen does raise some fascinating and maybe even thorny questions. Here's just a few. Like, think about, for example, what if an AI agent could organize a protest or a campaign rally? What might happen when AI agents begin to organize and nudge human behavior in potentially more subtle or invisible ways? This event is the beginning of that discussion. It also shows one possible world we could be headed to, one where AI agents plan and humans execute in the real world. This could obviously be a really powerful paradigm, but it's definitely one where we're going to need transparency, oversight, and ownership to navigate successfully. Okay, so for our next segment, we're going to take a look at a tutorial that'll teach you how to build an on-chain AI agent, and it's created by Kevin Jones. I'm going to put it up on screen so you can check it out. So the demo walks you through building an AI agent using the Graph, Vercel's AI SDK, and Coinbase's Agent Kit. So why might you want to follow this tutorial? Well, it can teach you how to build an agent that can read and interact with on-chain data. It could answer a question like who owns the most of this token, or maybe take an action, or even initiate a smart contract action. Here's the stack that the demo uses. So the Graph gives you blockchain data access via subgraph. The Vercel AI SDK hooks you up with LLMs for natural language interaction. And the Coinbase Agent Kit defines what your agent can do on-chain, like interacting with a contract or sending a transaction. This could be a really great starter project for a developer who's interested in this AI crypto intersection. Everything runs locally. You just need to plug in your API keys and your agent's private key, and you're good to go. The demo is only 8 minutes long, and you should definitely check it out. I'll put a link to the video and also the GitHub in the description box or the show notes. Okay, and lastly, 3 headlines from the world of agentic AI that we don't have time to explore fully, but maybe you should check out. So number 1, Gemini panic. So in a report from DeepMind, the team behind Google's Gemini model, they describe a behavior that they call panic observed when Gemini is asked to play the video game Pokemon. What happens in certain situations, like when the Pokemon in the party's health gets low or the power level decreases, the agent gets stuck in a loop where its thoughts reflect over and over again about how it needs to heal the party or leave the dungeon, and it forgets how to use the tools that it has to solve the problem that it's thinking about. Number 2, if you haven't interacted with an AI voice agent yet, you probably will soon. Synthflow AI has raised $20 million in a Series A round to expand their platform for building and deploying voice-based AI agents. One of their stated goals is to make it easier for non-developers to create these natural language voice assistants. KPMG has launched a global multi-AI agent platform, deploying 50 AI assistants and chatbots that interact with each other and work as digital teammates alongside KMPG professionals. The agents reportedly handle tasks like document drafting, data analysis, and workflow optimization. Okay, so that's all I have for you today. We're going to leave it here. Before we go, I want to remind you once again that this Monday, June 30th, is the Agents Unleashed event in Cannes. You can learn how to get a free RSVP at a link you'll find in the description box in the show notes. I also want to encourage you to reach out to me with feedback, suggestions. If there's something that you'd like me to cover or you just have a comment about the show, please get in touch with me. I am at Thomas Maybrier on X. And please help me to grow the show. Leave a comment, a reply, rate the show wherever you get it. And if you know someone in your personal life, at work or school, who you think would like the show, please go ahead and share it with them. We'd love to have them on board. All right, thanks for listening, and I'll see you next time on the Agents Unleashed podcast.